In the last video I showed you this setup and I explained it in detail. I also explained what you need in terms of hardware and what you need in terms of software. And also we did a little Hello World example. In this video I'm going to transmit using one network adapter and receive data using another network adapter. To do this I'm going to use a short crossover cable. I'm going to be sending one Ethernet frame over the wire, over the crossover cable. To do that I have to first set up the data in RAM to be sent. I have to set up the receive buffer, then I have to issue the send command, and then I have to wait for the frame to be received. As you can see, the frame is different in the send buffer, on the wire, and in the receive buffer. As far as the data in the send buffer is concerned, you can put anything in there with one exception. You have to be careful what you put in destination address. Other than that, you can put anything in this green field. Then when you issue the send command, the network adapter will insert the interframe gap, will insert the preamble, calculate the checksum, and send everything over the wire. When the frame is received, the preamble is discarded and the receive status is inserted and the 2-byte length is inserted and everything is transferred to the RAM receive buffer. So this is the content of the receive status register in your receive buffer. It has bits that indicate what kind of packet was received. Was it a multicast, was it a broadcast, or was it sent exactly to the MAC address of this network adapter? Over here we have some error flags and a receive status. I said you should be careful what you put in your destination MAC address. I said that because if your network adapter is configured to respond only to its own MAC address, then it will drop all frames that were not sent specifically to it. If your network adapter is in promiscuous mode, that means that your network adapter accepts all packets. Then it doesn't matter what you put in the destination address except for these 2 bits. Even in promiscuous mode, the network adapter will check these 2 bits. So now let me show you the code and let's run the code. All the code will be available for download on GitHub. If you are using this code and do not have a serial connection, you should comment out all the calls to serial functions, like this. Because if you don't have a serial connection, these functions will slow down your code significantly. The link will be in the description. So compared to the previous video, everything is the same except for these 2 files, definitions ASM and LAN ASM. In definitions we have all the adapter registers defined, like command register and its bits. In the LAN file we do the actual transmission. First we reset the NICs, network adapters, then we configure network adapters, then we do the transmit by writing to this adapter register. Then we wait, then we receive, and then we print out the received message, the received packet. The message we are going to transmit is this: hello RxTX, and this is the address of that message. In definitions we have defined the receive address, and we have defined the size. Note that network adapter will automatically pad the packet with zeros to meet the minimum required size of the packet, of the frame. To transmit, we first tell the network adapter where is the data to transmit, and we tell the other network adapter where is the receive address, where to receive the frame. Then by writing the size, we reset the OWN bit and the transmission commences. So now we can run this code. We first run the compile batch to compile the code. Then we reset the test machine and wait for the message to appear in the serial console. And there it is. Received OK. Hello RxTX. If you like this video, please like, subscribe, and thank you for watching.